Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back working over here on the wooden pattern for the big drum that we're doing for the John Deere Amazon cane mill. We've got our pattern pretty much glued up and ready to turn over here on the lathe. And I'm kind of excited about this today because I'm going to be kind of introducing a new machine for you guys. It's by no means a new machine for me, but I think this is the first time I've ever really featured this particular machine on my channel, particularly in use. I don't even think I've even really, other than just seeing it in the background, it's ever even been talked about. But this is a kind of unique and special lathe that we're going to be using today to work on this wooden pattern. And what this is a Fay & Scott, made by Fay & Scott out of Dexter, Maine, pattern maker's lathe. Now we're working on a wooden pattern. This is exactly what this lathe was designed for, was doing pattern work. And what's kind of unique about it is that it is a wood lathe for doing woodworking, but it is different than your typical wood lathe that's just done with hand tools. And that this one here is kind of a hybrid between a wood lathe and a metal lathe. Of course, a metal lathe has a saddle and a cross slide and compounds and all that kind of stuff for doing precision machining. Whereas a wood lathe, typically you're just using hand chisels, and just kind of freehanding it. When pattern work was being done, patterns were basically a wooden mold that was made for casting something, but they needed to have some level of precision to them, more so than just, going in there with a hand tool. Not to say you couldn't do it by hand, but if you're needing to turn a long, straight surface like this right here, having the saddle that moves up and down a carriage like on a metal lathe is very handy to do that. So they came up with the concept of these pattern makers lathes that kind of, again, is a hybrid between the functionality of a metal lathe, but for doing it on wood. This particular machine, I don't know the exact age on it. I don't think I was ever able to find a serial number or anything on it when I restored this. And I actually restored this machine back before I was doing YouTube videos, so it's been quite some time back. I picked this machine up at an ARNFest event. Man, it's been probably close to 20 years ago now. Between 15 and 20 years ago. And brought it home and anyway, restored it. I've actually used it on several projects in the past, but again, they were all kind of before I started doing videos. Just haven't had a need for this up until now. Big reason being is that a lot of my pattern work now is being done with 3D printing rather than making wooden patterns, but today we're going to be using it for wooden pattern making. Don't know the exact age on this machine. Looking at some of the old catalogs and stuff over on my VintageMachinery.org website. If I recall, then it's been a while and I haven't refreshed my memory beforehand. I think this machine was probably made sometime around the turn of the century, 1900 to probably 1920, somewhere in that window is probably when it was made. This is a flat belt driven machine. It was originally driven by the flat belts going up to an overland pulley system. When I restored it, I put a motor on here. I kind of built a little cage back here to kind of hold the frame. And I've got it hooked up on a VFD or a variable frequency drive, which kind of gives me some variable speed. I've got this little control box. It's mounted on a magnet, has forward, reverse, and a variable speed pod in here where we can do it. I can just kind of stick that anywhere on the lathe that I'm working and have access to it. So before we get going on this, the first thing I need to do is I need to take a couple of minutes and kind of clean up around this area. As tends to happen, when you have a surface area that can collect junk, it collects junk. And this machine has not been used in a while, so it has accumulated a bunch of stuff piled up around it. Mostly scrap wood, cribbing, stuff like that I use when I'm moving machines around. This just kind of has become the area that it has got piled in. So I'm going to get in here and kind of get everything cleaned up around this and get it in here. There's a few features I want to kind of show you on this lathe before we get started. And then we'll get started turning this pattern. All right, I think I've got this machine kind of unburied over here, kind of cleaned out around. We can actually get in here and start looking at it and using it. Couple of neat little features about this lathe that I wanted to share first off. This is what is called a gap bed lathe. It has got a gap that will open up right up here And to open it up and close it, there's actually a big crank back here on the back of the carriage, and when you crank that, it's moving it in. Right now it's closing the gap, which is fine for what we're going to do, or you can open that gap up. And if I remember right, it'll open up somewhere along in here and give you a bigger swing up there close to the front. Now, with this being a pattern maker's lathe, a lot of your work would have been done on a faceplate. So you'd have had a faceplate on here, and you would literally just screw stuff to the faceplate and work on big rings, pulleys, things like that that you might be making patterns for. When I got this lathe, it actually came with 2 of the cast iron faceplates. There's one of them I got on the back of the lathe back here. I'll talk about that in a minute. And there's one that fits on the front. They're both the same. They fit up onto this spindle. And I think, if I remember right, they were 2 different size faceplates. And actually both of them had larger wooden faceplates that were just made out of like 2x4s and 2x6s that would swing, you know, a larger diameter. This lathe over the gap will swing 36 inches, if I remember right, and you know, just over the ways here, smaller than that. I'm gonna guess, well, that's, you know, probably 24, 28 inches, something like that. I'd have to get out a measurement to measure it. It's irrelevant, really. But the fact that you can mount it on the back here, you can also mount it back there. And if you have a foot tool rest that sits on the floor, they actually made one. I wish that I had one. It's like a tripod looking thing that you can put up a tool rest in, a big heavy duty thing that would sit on the floor. You could swing something that went all the way down to the floor. So really, really large diameter that you could work off on the outboard end of the lathe. Again, back there, you would have just been doing it by hand. There would not have been the ways and stuff up here to do this. Now, when you're doing that really large diameter stuff and you're needing the features of the pattern maker's lathe here, where you have the saddle and the cross slide and all that, obviously if you look here, this tool is only going to come out to about right here. So you're limited in, you know, how far out on there you can go. But they got around that in a rather unique and clever way. Let me move you around and show you this. So for that large diameter stuff, again, over the faceplate primarily, notice how in the back it extends way back. And if you look, there's actually a cross slide handle back here in the back. So if you were doing faceplate work that was large diameter, you would actually, what you would do is you would put the lathe in reverse and you would work on the back side of the lathe, and you had this long piece that stuck out. For normal operations, that would have been in the way on the front of the lathe, but if you need that for the back side, you can spin it around and again turn it in reverse, and you're basically working on the back side of the lathe to get that large diameter. So I thought that was kind of a neat little feature. Let me show you something else, kind of a neat thing that had to get around on this. So at the time that this lathe was made, most of your chucks would have mounted on just a threaded stud on your spindle. So you would have had just a big thread, and your chuck or your faceplate would just screw up on there. It works great as long as the lathe is turning towards you and tightening it up. But when you're working in reverse, what can happen is that chuck can unscrew. A lot of people with older lathes that had just a screw-on type, that was a common problem when they were running in reverse. Your chuck or whatever could just unscrew on you, and that would make for a really bad day. So to get around that, what Fay and Scott did is they actually just have a straight shaft that goes up here on here with a key, and if you look right here in the bottom, there's a drawbar. This drawbar goes all the way through the spindle. There's a handle on the back, and basically what your chuck would do is it would fit up on here on that keyed slot. There was a center plug in the middle. You would tighten that drawbar up, and that drawbar would pull it up on there and keep it tight. So it didn't matter whether you were spinning forward or reverse, your chuck wouldn't come off. Kind of a unique, I'm sure there were other manufacturers that use that, but this is really the only one that I'm aware of that did this type of a chuck, which I think is kind of neat. So another little neat feature, I guess you could say, on this is this piece here that fits up onto the cross slide. This is for just putting a tool rest in for doing regular lathe work. When I got this lathe, it had this particular tool post on here, or this style tool post on here. It wasn't this exact one, although the one that I had been broken here on the end, it had been brazed up at some point in time. And what I did is I actually had this part recast. I was actually able to use the original part as a pattern, send it to a foundry, they sent it back, and I remachined this. This just fits down into the tool post here. You tighten that up, and then you can put a lathe tool rest up on here like such, and move that around. And with your cross slide and your saddle, you can position that where you want to run a regular lathe tool on there, and you can use whatever style tool post you want to put in here. However, when you were using this in more the pattern maker mode, like a traditional lathe, this would come off, and you could also put a compound in here, kind of like you would on a metal lathe, to put a tool cutter in and be able to use that, and also be able to put whatever angle that you wanted to put on it. Now, when I got the lathe, it did not have this part, and I was really wanting that, because for using it again for pattern making, having to be able to put a tool on here would be real important. I was fortunate that I found a person that actually had one of these lathes, and I think it was a little bit different size, but it took the same tool post, and I got with them, and boom, voila, now I have one. Now, I didn't buy theirs. What I did, I'm a little bit tight, I'll have to loosen that up to get it in there, but no big deal. What I did was, they were kind enough that they took theirs apart, and they made a really nice set of drawings for this right here. And once they did that, I took the drawings and I made a set of patterns, had the parts cast, I machined everything and put it together. So this was actually a compound that I made. It was made, from drawings made from an original. Get that back out, and made just like it. This tool post just fits up in there. You can actually take it out and whatever, and of course you got the piece up here on the top where you can put a whatever kind of tool holder you want up here. This would have had a lantern type tool post originally, but anyway, this was completely made by me and made to the original specs from an example that I was able to find. So I thought I'd share that. We're going to actually probably be using this tool post on this job, because I need to come up with a lantern tool holder or something to hold a tool in that we can use this for doing more of a straight cut using the lathe. So, all right, yeah, let's move forward here. Now, this particular lathe, on the saddle and cross slide, it's all manual. There's nothing in here that is power feed or anything like that. I think, if I remember right, I think Fane Scott had that as an option. They basically made the same type of a lathe in a metal lathe with a few different features on it. So, I'm sure you could have gotten one that had power feeding on it, but this particular one for wood, it's all hand feed, and that's just the way it came from the factory. Now, one little modification that I had to make to this lathe, I guess I didn't have to, but I chose to make to this lathe, was when I got it, the tailstock down here had an odd taper in it that your tools would fit up into. I want to say it was a Jarno taper, they're not very common. And finding tooling with Jarno tapers, it's kind of an oddball thing. It's an obsolete thing. Nobody really uses Jarno taper anymore, but back when this machine was being made, Jarno tapers were fairly common. So when I was rebuilding it, I actually changed the taper in here to a Morse taper, and I was just, fortunately the Jarno taper was a little bit smaller than, I think this is a number 2 Morse taper if I remember right. So I was just basically able to put this in the lathe. I kind of roughed in the angle, and then I used a tapered reamer, a Morse taper reamer, to go in there and ream it out to the proper Morse taper size, and that allowed me to be able to use more standard tooling on this lathe. And that's really helpful, because this takes the same tooling as my other wood lathe, as well as even some of my metal lathes take with the standard Morse taper. So I thought I'd mention that. And the other thing I'll mention is, again, I think I talked about this before, this little down here, originally this was a flat belt driven machine. It's still a flat belt driven machine, but it would have gone up to a counter shaft, and you had the step cone pulley here. And this was for speed control. You would have had a matching step cone pulley on the counter shaft that had been turned around the other direction. The ratio between these made it with a belt length was the same no matter which one you were using. But depending on where you belted it up on there, you had 4 different speeds for this lathe. It did not have the matching step cone pulley, unfortunately. And at one time I was seriously thinking about making a step cone pulley to go up here, and I may still do that one of these days. But the way I got around my speed control, like I mentioned before, is we just got a 3-phase motor on here. I'm using a variable frequency drive. The nice thing about a variable frequency drive or a VFD is that you can get speed control out of it, and I've got speed control here in this little dial. So I can just change the speeds. I'm only going from, I only got 1 pulley range in there, but the reality is with the motor control, I do have a greater speed range than I would have had with the step cone pulleys. So anyway, this little cage back here in the back is nothing fancy. There's a couple of angle brackets that was on here. I talked about how this piece was cantilevered out, or where you could have the tooling on there. They also had over here where you had some little brackets on here, and if I remember right, in the literature I was able to find, there was a kind of a piece that mounted on here that would go in and out. So when you were back here on the back, instead of using the cross slide, there was a separate piece that would go in and out, and it just rested on these. It would move back and forth on this cross slide, and it would just kind of rest on these little angle brackets. The angle brackets were on here, so I utilized the angle brackets to mount this on, and I fabricated a little cage. It's on a hinge. This is literally just hinged on there. The weight of the motor kind of keeps the tension on the belt, and anyway, that's how we did it. I got it, going up to my counter shaft here, and then that was my solution for getting a motor on here, because it did not have a motor on it at all when I got it. Well, guys, I've been playing around a little bit over here, kind of wanting to get this thing set up, and I've come to realize that I've got a couple little issues I need to just go ahead, address, take care of right now before I go any farther on this project. I mentioned that this cross slide, or the compound, I had made based on the blueprints years ago, again back before I was doing videos. And as I go to put this thing on, number one, the post in here in the bottom is just a little bit tighter than what it needs to be. And I'm like, you know what, to really fix this right, I need to knock that post out the bottom, put it on the lathe, and just turn it down ever so slightly more. I seem to recall that when I was doing this, that at the time I was working out at the museum, I was doing my machining work out at the museum, but yet this lathe was at my house, and I had made a measurement and put it all together, brought it back home, and it was just a little bit too tight. I didn't have the machine to go check it on, and it never got fixed. The other thing that I've noticed is that this cross slide is really, really stiff. And I know what's going on with that. When I did this, I did all the machining work, but this was never fine-tuned, scraped in. At the time that I did this, I didn't even know how to scrape. This was before I learned how to really do that. So I think what I'm going to do is, before I get over here and fight with this thing trying to make it work like it needs to, I need to take the time to kind of finish it out and do what was never done when we made it the first time, partially because I didn't know how to scrape back then. And I just this has never been used on an actual project before. So now this is the first time, okay, now, is the time to do it. So let's take this thing apart and see if we can do a little tuning to it and make it where it works the way it's supposed to. And it has been a long time since I have messed with this thing, but I remember that this has a removable gib that is adjusted. It's not a tapered gib, it's set by set screws, and that is how the original one was. On gibs, a lot of times the gib is tapered, sometimes they have the set screws in here. Yep, and the whole gib comes out. It's kind of was machined out of a piece of cast iron, and it's got a little key up in the top to kind of key it in place in there. So I got the gib out, and you can see it's been machined, but it's not been scraped. And the other thing I need to do is I remember right, you got to unscrew the screw up here to get it completely out. I'm going to take it back and see if it'll unscrew all the way out. I don't remember if it does or not. And it works. It's just tighter than it needs to be. And like I said, it just needs, it's never had that final little bit of scraping to get it going. Okay, I've hit a wall here, so I'm going to get something and loosen this little tapered piece up here, and I believe that will pull the whole screw out. Let me grab something to get that out with. Alright, there's my screw coming out. Now, there we go. So, you can still see the milling marks in this. So we need to work on getting this scraped in. I've got this piece off the lathe. If you look right here on the top, you can kind of see that little circular piece right there. It's got the center in it, and then there's a set screw. That set screw just kind of keys it in place, keep it from spinning in there. You pull that out and it would turn. That was just drilled right kind of in between there. Dutchman's key, I think they call that. But there is a center in the top of the actual stud and a center in the bottom. And what I'm going to do is I'm just going to turn this between centers. I put a center into my 3-jaw chuck that will fit up on that center. The chuck itself will actually come in contact with this little knob here, will come in contact, so that will replace needing to put a dog on here to turn this. I'm going to put my center up on the other end, and we should be able to turn that stud right back on the same axis that it was before. And it looks like this was sanded on or something trying to get it. I don't even remember what all was done or why, but we're just going to get it straightened out. So I'm going to go ahead and get my live center put in down here. We'll put a tool in here. We'll just shave that down ever so slightly to get it to the size that'll work, and go from there. So let me get set up to do that. So I got my work in here again between centers. So we got a center in the chuck, we got a center on this side, and there's just a little piece sticking out that engages with the chuck, and that's what's going to drive it. So according to my measurement, I only need to take about a couple of thou off of this thing to get it to fit. Going to kind of come in here and just barely touch off, and we'll just run down through there, just kind of fuzz it a little bit, and I'm just going to kind of take it off, take it back there to the lathe, and we're just going for a good fit between the two parts. Let's see where this ends up now. Alright, that tool post fits beautifully now. Very happy with that. So now I want to start scraping this in. Again, this was just machined, milled, and it's not the smoothest surfaces in the world. We're going to fix that up by scraping. I'm going to start by scraping this bottom here flat on my surface plate, and then we will use this as a master over here to make a matching surface. But we need to get something to work with, so we'll go ahead and get that started first. Got my part over in my vise, just holding it in place, and what I typically do when I'm scraping, we've got a off the milling machine flat surface. So when I say flat, it's flat but not super flat. There's going to be some variability in there. What I like to do with an unknown surface like this, or something that's just off the machine, is I like to go in here and just kind of blindly put a crosshatch scraping pattern on it, and then take it over to the surface plate, glue it up, and then we really kind of start from there. I don't really like putting it on the surface plate until I've at least put a crosshatch pattern on it. So I'm going to start with that. I'm going to be power scraping. I'm using my Bi-X power scraper, and we're just going to do a blind crosshatch, and then we'll start scraping it in from there. So let's do it. I'm just going to do some lines here at a 45-degree angle, then I'll come back and go 90 degrees to that. So we'll just start putting the pattern in here. clean this up just a little bit. Let me get a stone and knock the burrs off of it. All right, I'm going to take that over to the surface plate. We'll put some blue down and we'll see how flat that is. The surface plate will tell the story. I'm at my granite surface plate. I have come in here and cleaned this surface up with some Windex and towels. Got it, all the trash and dirt off of it. We're going to just take a little bit of this. Whoops. Needs to be shaken up, it looks like. Blue has settled out. I'm just going to shake it up real good. Just going to give me a little area here. I'm going to take a roller and just kind of roll it out here on the table. We want a little thin layer of this blue dye or ink. I'm using a product called Canode. I don't think you can get this anymore. It's be fairly available. Heard some people saying they've had trouble getting it. All right, we've got a thin layer on the surface plate. The surface plate is extremely flat, and we're just using it as a reference surface. What I'm going to do is rub this on there. Let me kind of feel, do I feel any? It feels like it's pretty flat. I'm hinging it. It's hinging about right there, and it's hinging down here. That's telling me that's probably a high spot right there. And I flip it over, and you can see we got contact here and over here, but it's not contacting on the corners. Can you see that in the screen? So to get this flat, we need to scrape off the blue spots, and we're going to lower that area down. We'll repeat this process and kind of go back and forth until we get contact from one to the other. The goal with scraping here is that you want to end up with a surface that has little blue spots all over it. It's not going to be a solid surface as if it was ground. You want to have little oil pockets. You want to have points of contact that are uniform, spaced out, rather than just solid contact from one end to the other. If you have solid contact, you have two perfectly ground surfaces you put together, they stick. When you have points of contact and you got oil in between there, it slides, and that's what we're kind of going after here. The first thing is we need to get it flat, and while this was flat off the milling machine, it's, you know, it might have been flat within a thou, but we want to get it flat within, you know, 10 thousandths or even 50 millionths of an inch to have a nice flat surface. Let's go over there and do some scraping. We're just going to scrape off the blue spots, and we'll come back and check it again. And it's just a process going back and forth until you get the surface you're looking for. Back over here at the vise, I got my scraper out, and again, I'm just going to hit these areas that are blue. I am going to do two directions. We're roughing right now. We've got a good bit of material. We're not making any contact in these two areas, so I'm just going to kind of hit that one area, then I'll come back 90 degrees to hit the other area. When you start fine tuning, I usually go in one direction at a time, but for roughing, I'm going to kind of cheat and do two passes and go from there. With scraping, you know, you might be taking off a couple of 10 thousandths of an inch. We're not moving a lot of material here, so it's kind of hard to mess it up unless you just sit there and stay in one spot and dig a hole. We want to make fairly quick passes across here. This scraper is moving in and out, so we want to have, that's an individual scrape mark, and we want to have individual lines of scrape marks. We don't really want the scrape marks overlapping in one pass. You want to come back the other way, they will overlap in that direction. You kind of get that checkerboard appearance. So let's do it. So I made another, I don't know, 3 passes, I think, and I'm pretty happy with where we are right now. So what I've got is those little individual points of blue going from one to the other. It's fairly consistent. We've got coverage from one end to the other. Got a couple of places, like maybe this little corner here and this little corner here, where there's not a whole lot of points of contact, but the important thing is there is points of contact in there. It's just not all the way across. I could keep on scraping this, make it better, but for what we're using it for, this is going to be fine. So now that I've got a surface that is much flatter than what it was to start with. We're going to use this surface as our straight edge, as our reference surface. We're going to blue this up, and then we're going to go actually print it against the part that's going to be rubbing against it. We know this is flat now based off of the contact that we got on from the surface plate to here. And so now we'll use this because we can't get the other part on the surface plate because their part's higher than in area. So we'll use this to do it with. So let's do that. I'm going to get my other part. We'll get it over here in the vise, and then we'll blue this up and use it as a reference. Part, and we'll let that transfer over. Alright, so we're making contact here. I'm just going to go back and forth, rubbing the two parts together, and we'll pull it off, and I can see my areas. Now, one thing I'll note on this is that the gib is going to be kind of in here. It's contacting on the outside from about here in. It's not actually contacting in here. It'll be contacting on the dovetail, but not in here. So I'm going to be concentrating out here. This side here will go all the way to the dovetail. And I can tell that we're making contact here and a little bit over here. So I'm not going to make you guys watch all this. You just saw the process. It's the exact same process. It's just back and forth until we get it like it needs to be. So let me work on it, and we'll get those two pieces in good contact with one another. Yeah, I've been scraping on this for a little while now, and started out it was kind of heavy on this end and got light up here. I had to do what was called step scraping, where you kind of, go almost like three quarters of the way, halfway, and a quarter of the way, and you kind of bring this end down a little bit. And it's really still just a little bit on the light side, but I think I'm ready to do the dovetail, because I'll come back and check it all at the end. It'll probably move a little bit after I scrape the dovetail over here. But man, this thing is sliding. I can tell a huge difference in just how well these two parts are just sliding compared to the way they were when we first started already. So we're making great progress on it. I'm going to get a straight edge, and we're going to do this dovetail over here. This is the dovetail side that actually, I guess we could probably just go ahead and blue up both dovetail sides on, which side do I want to do? I got to think about which side I want to actually scrape first, and then we'll come back and do the other side and match it. So let me get that going, and we'll go from there. I'm going to work on this side first. I think this is the dovetail. This is actually the solid side. The other side is the gib side. So this side, the actual gib will get scraped, but not this surface in here. So what I'm going to do is we'll start by doing just a rough pass in there again to get a good surface to scrape off of. And this time I'll be using a straight edge that's got a dovetail edge on it. This happens to be one of my 9-inch straight edges that I've have designed and have been selling and making. But we will blue up the surface there. We'll come in here and we'll just kind of rub it back and forth like this right here. Transfer the blue and work until we get good contact in there. Now once that's done, we will use this surface to match the other surface. That's the process. Let's get her done. So I don't know how well you can see that, but I've got pretty good contact on this inside dovetail now. So now we will use this again as the master. We'll go over to the other piece and we will compare them and get the two sides where they are running pretty smooth with one another. So let me get the other piece up here and figure out how I'm going to hold it for scraping, and we will check it out. I've glued up that surface on the inside, and now we will, let's see, over here and use it. I'm pushing down on the bottom, and I'm also sliding back and forth in there, so I'm really kind of focusing on this dovetail. But we'll pull it out, and I can tell that my angle's a little high on the top. It's got a blue mark all the way down the top, nothing touching in the bottom, so we're going to have to kind of relax that angle back. I'm going to get out the scraper, we'll go to work on it, and same process as before, just redoing it over and over until you get that coverage you're looking for. I'll bring you guys back. So I finished this side over here, got it looking good, and on the other side, this is the gib side. I'm just using this one with the straight edge, and I've got it looking pretty good as well. So I think I'm pretty much through with the scraping on this. I still need to scrape the gib itself, and then we'll try to put this whole thing back together and see if it has smoothed up like I hope it should. I think this is going to work a lot better now that we've had a little bit of scraping in here. We got much better mating surfaces than we did before. So I'm going to go get the gib. We'll just do it on the surface plate because of the way that gib is designed, where you have set screws. It's not like we got to actually scrape it in on the part. We just need to get the face flat, and when you tighten up the set screws, it'll kind of self-adjust to the mating surface. So let me go do that real quick, and we'll have the scraping knocked out. I think we got all our scraping done. Let's see if we can put this thing back together. I'm going to start by putting just a little bit of whey oil on the surfaces here. A little squirt up there in the screw as well. This way. There we go. I scraped in the gib. I just did that over on the surface plate. I'll go ahead and insert that. Let me put a little oil on it first. And the gib is adjusted over here on the side with these little set screws. I'm just going to kind of snug them up. Slides beautifully. I love it. All right. Collar here screws up into the base. I did make a little modification so I don't have to put a pair of pliers on there. I just put some flats in there that a wrench will fit up on. That will enable us to tighten that up properly without having to mess it up. And there we go, nice and smooth. I like it. That is a huge improvement over what we had. Huge improvement. Let's go drop it onto the lathe now. Let's put this in here. So now that fits right down on there. Much, much better. And we can tighten that up right here. I'm not going to do it right this second. Our compound name slides just really nice. Do it one-handed. Before it was taking pretty much all I had to do that. I think we got that thing in tip-top shape now. Well guys, I'm much, much happier with this now than I was when we got started. And I'll be honest with you, when I came over here, I had forgotten that there was still work to be done to this thing. Once we got it on here, I'm like, yeah, we never did really finish that thing. So now this thing is finished and knocked out. I was not planning on having to do all this today, but now's the time to do it. So we just got it done. Next problem, I guess you could say, that I have is that I also thought that I had a lantern tool post that would fit on this. A lantern tool post, if you're not familiar, it's an old school type tool post that you would use with like the little tool holders with the rocker up underneath it. We don't really use them a lot in modern machining. We use more tool posts like the Aloris tool posts or things that are a little bit more sturdy, but on the old school lathes, those lantern types were very common. And for what I'm going to be doing, holding high-speed steel cutters, the lantern type is what I need for this, rather than putting like an Aloris tool post on here, because I'm not going to be running, you know, insertable tooling and that kind of stuff, I could probably get away with it, but I don't need it. I thought I had a lantern tool post over in my cabinet. I don't have one, at least I can't find it. So I'm gonna have to source me a lantern tool post for this. That is gonna delay me a little bit in this project. It is what it is. Like I said, I thought I had one, but I didn't go pull it out to make sure, and now I'm needing it and don't have it. So always a bad thing. Better to have it and not need it than to need it and not have it, and I'm in the need it and not have it mode right now. So I'm gonna have to go find a lantern type tool post to fit on here, and once we get that done, we can hopefully go over here and get this turning done and get this pattern knocked out, because we are really close to having it done. So I'm kind of at a stopping point. I think we've got enough content for more than enough content for a video here, so it's probably gonna be a long video anyway. So let's cut it off and call it a wrap right here. Guys, with that, thanks so much for watching. Please subscribe if you haven't already. Those thumbs up, comments, always greatly appreciated. Big, huge thank you to those who support the site financially through Patreon, PayPal, etc. Also now through YouTube memberships. You can join through YouTube and make a little extra contribution there that really helps out a lot. If you haven't already, hit the subscribe button. That's needed as well. And with that, we're going to get out of here. Again, we'll catch you on the next video. As always, thanks for watching.